Okay, welcome everybody to this webinar about ASDs and maintenance. So here we see the various topics we will cover in these webinars. So first is briefly introduction to ASD systems and components. Then we look for the maintenance activities and then performance tests, and the last question and answer time. My name is Zeno, and I work as a team leader, customer support for Securito International. So let's start. What is an aspiration system and what are the components? I imagine that most of you already know what is an aspirating system, but we just give a briefly introduction for people that doesn't know. So an aspirating system is a system consisting in a network of aspirating pipes and an aspirating smoke detectors. So aspirating pipes is a set of dedicated pipes and fittings, and on which sampling holes are drilled and through which the air from protected environment is transported to the aspirating smoke detector. The smoke detector is inside of the box and analyze the air and aerosol from the aspirating device. So there is a fan or a pump inside. Each aspirating device may contain one or more sensors. What you can see in the picture here, we got two detectors because we cover like ambience on the ceiling, and we saw one area, and the second one is used to cover another area that is on the fourth floor. On the fourth floor. Let's see the components of an aspirating detection system. So it's not only the ASD's unit, but there are also other accessories that you can find. So there is always an external power supply to power out the unit. And this power supply has to be certified for EN54 or UL, depending on the market. This power supply is complete with the battery inside, and so it is also it also needed to be maintained during the maintenance operation. Then we can see we got the reporting to the fire alarm control panel. So usually we got always like alarm for every channel and a fault. And then most of the time there is also like an input to make the unit reset. Then you can see here there are other accessories that could be present in the system. For example, there could be like a remote indication panel for the end user or for technician. Then there is a possibility to have like a connection with the PC for the maintenance and for the configuration. And then we can have some other accessory like external filter in case that there is like a dust environment. And all these accessories, when present, they has to be maintained as well. Now we have a look to the pipe network and the accessories. So these are all most of all the accessories that makes the pipe network. As you can see in this picture, there could be like extra accessory like automatic blowout device in very dirty condition. There could be like a water separator in case of high humidity. There could be like a dust trap that is also used in very harsh environments, and all these elements, when present, need to be maintained. Now, this is the operating principle of the aspirating systems. So as you can see, there is a fan that it is used, or pump. In our case, is a fan that aspirates the air through the pipes and through the sampling holes. Here in this picture, you can see there is a model with two detectors. So the air is sampled through the pipe, passing through the smoke detector, and then it goes out through the exhaust pipe. As you can see here, we got an airflow sensor. This element is very important because we need to constantly monitoring the airflow to be sure that the pipe is okay, so it's not like obstructed or open. And this airflow value has to be constant all the time. So during the maintenance operation, we need to check it out and be sure that it is at the nominal values. So here we can see the detector inside. In this specific case is an ASD 535. As you can see here, we got the pipe inlets. In this case, we got two pipes because we got two detectors inside. These are the detectors. In our case, these detectors are replaceable because in some regulation, it is prescripted that the detector, for example, need to be changed every 8 years or 10 years, depending of the regulation. So in our case, we can exchange this detector, and we can do maintenance directly on site. Then you see the position of the airflow sensor. So in this position, then here we got the all the terminal blocks for the connection. Here you can see the relay. So in this case, we got 3 relays because we need to connect to the fire alarm panel, the alarm channel 1, alarm channel 2, and the general faults. And this is the rear of the ASDs, where you can see the air circulation. Now let's have a look to the front on the cover. Here we got like compulsory LEDs that has always to be present in all the ASDs. Particularly, we got a green LED that show the system that if the system is in operation. So that means the ASDs is on. Then we got alarm LED, one per channel, and indication of faults. So there could be like a general faults or like detector dusty or detector dirty. Optionally, we can have also like a small smoke level LEDs that indicate the presence of the smoke in the detector. And these are for channel 1 and for channel 2. So the green LED system in operation, alarm and fault are compulsory. So in every ASD detector are present, and also this LED we will see has to be tested. So they have to work properly. Another component of the system that is most of the time present is the configuration software and diagnostic software. This helps us for also doing the commissioning, of course, but also doing the maintenance. Because whenever we connect this software, we can display the status of our ASDs. So as you can see, we can display them graphically, the airflow level. So we need to check if the airflow level is at the nominal value. We can check the eventually the presence of smoke into the detector. And then you can see here, we can check the sensitivity that has been set up into the detector, and the alarm status, of course. Another important things that is like one of the let's say components of the ASD system is the Flowmeter calculation report. This calculation report is fundamental to of course, when you design a system, but also when you do the maintenance, because this Flowmeter calculation report gives you all the parameter that has to be like set it up on the ASDs, and these settings has to be all checked up during the maintenance. So, for example, in this like small example, we got the detector with 2 pipe. As you can see here, we got like the different value of sensitivity for channel 1 and channel 2. Here now is displayed the EM54 version, so where we distinguishing the 3 classes, A, B, C. So C is a standard sensitivity, B is enhanced, and A is very high sensitivity. We got the fan level that has to be set up on the unit, and we got the transport time. These are all very important things that we have to check it up. We will see later on the maintenance activities. So initial and periodic maintenance activities. So there are a lot of reference standards for maintenance testing of aspiration detection system, but most of the time are country specified. Well, they exist, so we cannot like have one for all, but you need to check out in your country. However, we can identify common maintenance activities that can also meet specific requirements. So generally, the maintenance activities are divided into. There are initial inspection activities. For example, you are an installer and you are taking over for the maintenance of a system that you did not install, so a system that you don't know. So at the beginning, you need for maintenance, you need to check out if the system was like configured well and if it is works well. And then there are like periodic activity that is like routine maintenance that is carried out on the system at a specified intervals depending from the reference standard. For example, we can have like periodic maintenance every 6 months or at least once per year. So you need to check out your standards. So what is important to know when we do maintenance on the ASD system? So an aspirating detection system is assimilated to collected type detectors, so the zone alarm. So in this case, the two maintenance activities, initial activity and periodic, will be the same. So there is not like any difference. So for the same reason, because these detectors are assimilated to collected type detector, if in the installation are present more than one ASDs, they have all to be checked during the periodic maintenance. So that means that if I got 10 detectors, every time I do maintenance, I have to check all the time. I cannot like check, like, for example, 50% first 6 months and the second 50% up at the end of the year. So they all need to be tested at the same time. So necessary documentation and instrumentation. So as soon as you approach maintenance of ASD system, you need to collect documentation about the system design. Of course, you need to collect manuals and certification of the product that's been used. And you need to have, like, most of the time, there is also a maintenance register where you sign all the activity you do during the maintenance. So for ASD system is very important to check if the Flowmeter calculation is present, because this, as I said, this Flowmeter calculation contains a very important parameters such the length of the pipe, the number of sampling holes, and their diameters that at the beginning has to be checked up, particularly if the system was not installed by you. Then you got the information about the sensitivity level of the system according to the various classes that they has been designed. So ABC for N54 or NFPA for standard high or very high sensitivity, and the maximum transport time. Alternatively to the Flowmeter calculation, it is also accepted to use the appropriate manufacturer documentation, where all this information are indicated. So if the Flowmeter calculation is not present, check if the consultants they made a project following the indication to the manuals. And then last, you need to have the test instruments prepared for this purpose, and usually are instruments that are like suggested by the equipment manufacturers. So I numbered all the activity that has to be done in the ASD device. So first of all, you need to block or deactivate the alarm and the remote alarm signal to the fire alarm control panel. Then you need to check the aspirating pipe and any unused inlet connection plugs are correctly installed in the ASDs. So you need to check out that the pipes on the detector unit is installed correctly and there aren't any leakage on it. And then you need to check the air outlet that has to be clear, and then you need to clean if necessary. So in the case the ASD system is used to monitor equipment, you need also to check the pipes, of course, and all the connection that goes through the cabinet, for example. So then after these checks, you can open the detector cover and you need to carry out the following checks. So you need to measure the operating voltage and you need to check if it is in the current range. You know that nominal voltage is 24 volts for this unit. Then you need to remove the primary power supply on the power supply unit and measure again to check out also if the power supply works well. You need as well to check the status of the batteries inside of the power supply. Then you need to check the configuration parameter of the unit. So sensitivity and aspirator speed according to the design data, because you know that in the system, maybe you can have like several ASDs, but if the pipe network is different, you got a different configuration on it. So even if they are all the same, that does not means that they got the same configuration. That's why it's important to check it out. So here we can see an example. So here we got from the Flowmeter calculation, we got different sensitivity for of course, the different classes. For example, if we take like standard classes, that is C, or for example, NFPA 72, the value of the sensitivity for channel 1 and channel 2 in this case are the same because the pipes are the same. You see, I got the value of expressed in percent obscuration meter, so is the sensitivity is 2.974, and the fan level is 3. You see, this is the data from Flowmeter calculation. So then I need to connect to the unit, or I need to check it out from the display. I need to check that the right sensitivity is right on the unit. So in this case, you see, I got for the alarm, I got sensitivity of 2.978. That is correct, and the fan level is at 3. So these parameters are correct. So I can proceed. So then another activity is like to check the event memory, to check if something happened, to check the detector status, if there was any faults, you need to check it out. And then it's very important, that is an important activity, is to check the airflow value for each aspirating pipe and compare it with the commissioning report. So what does it mean? When the system has been commissioned, the installer has like set the nominal airflow value, and we need to check because this airflow value has to be always constant. So for example, whenever we see that this value of airflow air is going down or is going up, we need to check. We need to make a check. So in this case, in this example, we got a standard set sensitivity for the airflow fault that is plus minus 20%. This one is like a standard for the EN, but it's also like the same for the NFPA 72. As soon as we see that we got like an increasing of this value, so for example, if we got like 100% is our standard value, whenever we see we got an increasing, for example, 110%, or we got a decreasing, for example, 90%, then in this case we need to check out if the value decrease an obstruction, or if the level increase, we got like a leakage. So in this case, we need to make some check on the pipes. So what we have to do? We have to switch off the power supply on the SD unit and clean up the various components. So, example, we need to clean up the insect screen or filters. So this is the case that the value is going down. We need to cleaning of the sensor and housing. So we cannot remember that we cannot open the sensor, but we can just like clean up the housing and only externally. And we can check in and possible replace the internal or external dust filter, and of course in accordance with our instruction. So Zach, I stop now for a few minutes if there are like any questions, and then we proceed. Zach, I cannot hear you.
We have a few questions, Zeno, and the first one is, how often should maintenance be carried out on an ASD system?
Okay, it depends. So if we mean routine maintenance, the regulatory maintenance must be followed. If not otherwise prescribed, as a rule, at least once per year. So in some country, regular maintenance is like twice per year. In some countries, one per year. You need to check it out in your country, but at least once per year.
Thank you. The second question is, why are ASD systems assimilated to collective smoke detectors with regard to maintenance?
Yeah, it's because they generate a zone alarm. So each detector within the ASD system is assimilated to a conventional or a collective line. That is the reason.
Mm-hmm. The next question is, are all ASD systems configured in the same way?
No, the configuration on the ASD system depends on the length of the pipe and the number of holes and the detection class. So you need to check out the Flowmeter calculation.
Mm-hmm. The question I've got from the chat is, when we have a drop in the airflow, is it needed to clean also the airflow sensor?
Yeah, this is it depends. So sometimes you need to check it up. So yes, you can. So, but then it depends of the application. If you see after the maintenance, when after you have to clean it up the pipes, then we will see how to do that. And after like changing the filter and placing the filter, if you see that the airflow is still like not come back to the nominal value, you can check the airflow sensor. But you need to do it carefully because the airflow sensor is very sensitive and it's very easy to get damaged. Yes.
The next question is, what should I do if there is no flow meter calculation or design on a system?
Yeah, that is the problem because flow meter calculation is very important. So first thing is you need to ask to the consultant or to who has designed the systems, because you need to recover all these this design. Otherwise, maintenance became very difficult, because in this case, to check the performance of the system, you need to make real file tests to check if the system is okay, because you don't have any reference to do the functional tests.
Mm-hmm. Thank you very much. So we don't have any further questions at this stage, so we will get in more questions and ask them during the end of the webinar. Please go ahead.
Okay, so okay, then then we see if it is necessary to clean the aspirating the pipework in accordance with the 0.5. So whenever we see there is like we see that the airflow is decreasing. So what we can do, depending of the ambient condition, we can clean all holes in the aspirating pipes. And for this purpose, I suggest you to use pipe cleaning sticks. And if the sampling holes are not accessible, you can use an air compressor that has to be oil-free. So you can blow the air into the aspirating pipe. And in this case, the best thing is to install or to have installed three-way valves. So that makes this operation quite easy. And or you can also use our cleaning kit that you see here in the picture. So this one, okay. So there are two operations that has to be made. The first one I suggest you is to vacuum for 60 seconds each pipe to remove particular or dust that is will be like deposited inside. And after that, I suggest you to blow in air for other 60 seconds for each pipe to try to remove the dirt and the dust around the holes. So this time are like just an indication. You can also like make like 2 minutes or 3 minutes. It depends of the ambience condition. What is important to know when you use this tool or air compressed air, you are never to blow air into the smoke sensor or the fan because you could damage the detector. So be carefully. Okay, so once you have clean up the detection pipe, you can restore the power on the ASDs, and you need to wait for the fan to reach the normal operating condition. That will take at least more or less 5 minutes. Then you read the airflow value again. So if the value is still not with the tolerance, the airflow monitor, the airflow value has to be recalibrated. So what does it mean? That we got, in our case, a nominal value at fixed at 100%. So during the maintenance, I found this value at 75% because there was like obstruction in the filter and so on. So you made everything, you clean up everything, and then the air value drop to goes to like 95% or 98. So in the case you are sure that you made all the proper maintenance, you can make a new recalibration. So to make the airflow to the correct value. So so this is very, but when you make this operation, it is very important to be sure that the pipe and the holes are properly cleaned up, because, for example, if you perform this initial reset and without do the proper maintenance, what could happen that you reduce the performance of the detector, because what is important is to restore the nominal airflow value. So also, you know, in the question there is like somebody asked about the necessity to clean up the airflow sensor. In this case, if you see that after all the maintenance, the value is not like rising 100%, in this case, you can check it up the airflow sensor, and then after that, you can make the initial reset. So then you need to check fault and alarm signaling, and to see if there is a correct transmission to the fire control panel. So to do that, just to check the connection, you can use like relay tests. So and you don't need to make at this stage, you do not need to make a real fault or real alarm. You just like need to use the relay tests. So, and then you need to check to make the signal LED tests. To do that, you need to press and hold the reset button for at least 10 seconds. So you check that all the LEDs works. This is important. Yeah, alarm and the relay fault test. Yes, we talk about that. Functional airflow sensor tests. So airflow sensor need to be checked if it works properly. So to do that, you need to create like an obstruction, and you need to create like an open pipe. So, and you need to check if the airflow value change. So the best thing is like you can use for like to simulate obstruction, you can use a valve like this. To simulate an open pipe or leakage, you can use these openable joints. The best of all is to use the three-way valve, because with the free whale valve, you can make like cleaning of the pipe, and at the same times, you can make both obstruction and opening. So last but not least, you need to perform functional alarm tests with smoke for each pipe and from the farthest hole, with the verification of transport time. So this test is fundamental, I have to say, because you check out if the system performance are okay or not. So we see now some example. This is about the testing equipment you need to have. So you need to have for this test a smoke pen. You need to have like a pole tester. This one is a special design for ASD systems, or you need to use smoke pellets. So now let's see in this example. Here I got, in this example, I got a very simple installation with a pipe with the five sampling holes. And here from the Flowmeter design, I got all the transport time for every single hole. So you can see the farthest sampling holes transport time is 40 seconds. What does it mean? I means that for the test, I need that to make like a smoke to the farthest sampling holes. I need to verify that the smokes is coming into the unit within 40 seconds. After that, after a few seconds, you will have like a fire alarm. So if this time is more or less correct, that means that installation is good. If this time is like too high, that means you got a problem in the installation. So that means the pipe is not like installed properly, or you got like an obstruction, or so this test is very important. So in the case I got a linear pipe and only one pipe, I just need to check to make one test on the farthest sampling hole. When I got I got branches, so more than one pipe, I need to test every single pipe, because maybe in the example you test only this, you test the ASDs works, but you don't have the guarantee that all the other pipes work properly. So you need to test all. So what's happening if the farthest sampling hole is not accessible? So in this case, the best thing is to place test points in the reachable position. For example, this one is quite high building, so I can install the pipe down in a position when they are reachable. And these are you see in the picture testing point, so they are normally closed, and you open during the maintenance to make the tests. So they are called testing points. Okay, now we give a look to the performance test according to FIA Code of Practice. So in some cases, it is necessary to carry out real tests that are called the performance tests to verify the effectiveness of the installed aspirating system. For example, whenever a system has been designed has been like performance design, so it's a special application. In this case, maybe you needed to make the real file tests, so the performance tests, or whenever it is requested from the consultants. So now we show you an example of a real file test that has been done in the installation in the warehouse with the ceiling protection at the height of 15 meters with the standard sensitivity. So you see this in this chart from the FIA Code of Practice. This is like a ceiling protection and standard classes. So in this case, we need to use, so you see there are different type of test. In this case, we do this test with pellets. So here I specify the quantity of the pellets. So these are the instruments we have that have been used. So you see there are smoke pellets in different quantity. There is like this heater with this seminary, and then this system is placed on the floor, and then this is the smoke that's is produced. So let's see how this instrument is made. So it does not exist in the market, so but you can make one by yourself. Is quite easy. You just need to have like butane gas burner or electrical heater with a power of 5.8 kilowatt. Then you need to have like a metal plate, at least 200 millimeter square, a metal chimney, and there's to be 2 from 6 millimeter thick, and in cylinder one with the high with at least 100 millimeter diameter, and with the high at least 150 millimeter. So either the base of the chimney of the metal plate should have holes to provide ventilation. So usually you see that you make like several holes on the base of the cylinder just to make the air come in. Then you need a clock or a timer, and the pellet, of course. And then, you know, is a thermal camera or like a thermometer to check out the ambient temperature. So this was the warehouse that where this test has been made. So the area is quite big. So many several ASD has been used. They're all with the same design, as you can see. Then here the file has been made in this position. Okay, all the units were on. So this is the procedure for these tests. So we need to place the metal plate up on the heater, and then we need to put the pellet inside. Then we on the top, then we place the chimney centrally around the pellet. Then we start up we start the heater, and we start until the pellets start producing smoke after a while. And then we need to leave the heater on for the second that are indicated in this other chart. So you see, this is from the building height from 10 to 50 meters. This is the difference of temperature there is from the floor to the high. So if the difference is like from 3 to 6 degrees or to 9 to 12 degrees, you see you need to increase the burning time. So in this case, the difference from the floor and the ceiling was like within 6 degrees. So we need to leave the heater on for after it starts generating smoke for 20 seconds. So when this time has finished, you need to stop the heater. And then if the system is performing, you should like recognize an alarm within 180 seconds. Okay, so if you got like wherever in this whatever of this detector goes in alarm, that means that the system is performing. So this is the example that what's happening in this installation. So we place the pellet in this position, and the first detector that went in alarm is the opposite one, then this one, then this, and for last this one. What does this means? That because there are like air current in the building, we don't know exactly where the smoke goes, so it could go in the different direction. So what is important? It is important when you make this test, if you got more than one ASDs in the area, it is important that all the ASDs are on and working properly, because in this case, if I got only the ASD number 5 on, I will never have an alarm. So maybe the alarm was like, it was going alarm after the 180 second. So last, during this test, if you got like your software connected to the PC, you can also record this test. You can record this graph, so you can check out what's going on into the ASDs. Okay. So the webinar is finished. If are there any other questions, Zach, we got like a few minutes, so we can answer them.
So we've got some questions, Zeno, and the first one is, how do I check the functionality of the airflow sensor if there is no obstruction or opening valve on the pipework?
Yeah, so that I mean, that case is more difficult, because you need to make an obstruction on the sampling holes. So you need to obstruct at least 20% of holes, and about to check out the pipe latching, you need to manually open the pipe on the system.
So I've got another question in the chat. Client of ours is asking, can you quick give info on how properly to clean the airflow sensor?
Yeah, so airflow sensor, you need if you need to clean it up, you need to remove it very carefully. So you need, of course, to power the unit off. Everything has to be off. You need to disconnect the cable. You need to extract it very carefully because it's very fragile. And then you need to clean up, not with the hand. You need to use like a towel or like cotton stick. So what is important, you don't have to touch with the fingers, because otherwise you compromise the reading of the airflow sensor. Yeah.
So next question, can aerosol cans be used to test ASD systems?
So aerosol cans is not the best test to use, for two reasons. The first is that this aerosol can leave residues because you need to spray a lot. And the second thing is that maybe you don't have, particularly if you are very far away from the detector, maybe the particle duration may be insufficient to generate an alarm, because the aerosol can has been made for the point detector. So it is necessary to be close to the detector with that. Yeah.
The last question I have is for functional testing. Can I test other holes besides the furthest hole?
Yeah, of course. So the first one is like we'll say compulsory, but for functional test you can also check any other sampling holes on the pipe. Important thing is to test one by one. So, and don't test them at the same time, because of course in that case it's not like a performing test. It was, but you can, yes, you can do that just in the case if you can test, of course, more than one and not only the last one. Yeah.
Thank you. So we don't have any further questions